Now's a good time to remind ourselves that the concentration of calcium is exquisitely controlled inside the cell. It's such an important ion for signaling that tight control is necessary to prevent unwanted events. Now that we appreciate the role of calcium in synaptic signaling, how do we make sense of the minis and EPPs? The breakthrough clue came from a close observation of the amplitude of EPPs under low calcium conditions. Recall that EPP's size varies with calcium concentration. Under very low calcium concentrations, the EPPs will be quite small, not much bigger than the size of the mini EPPs. When Katz plotted a histogram of EPP amplitudes under low calcium concentrations, he saw something striking. Curiously, the histogram revealed that the EPP amplitudes seemed to occur in multiples of the mini EPP amplitude. That is, under very low calcium concentrations, the stimulated EPPs seem to be the same size as the minis, or double the mini amplitude, or triple, or quadruple, and so on, and sometimes no EPP would be evoked at all. In a stroke of brilliance, Katz understood what his data was telling him, and he hypothesized that rather than transmitter molecules being released individually, they must be released together in packages of approximately fixed number. Said another way, neurotransmitter release in synaptic transmission is a quantized process. Rather than continuously flowing out of the presynaptic neuron, neurotransmitters were released in discrete quanta, or groups of neurotransmitter molecules, that all spilled into the synaptic cleft in one go. The mini EPPs represented the release of just one of these putative packages of neurotransmitter. And the quantized nature of the EPP, which occurred in multiples of the mini's size, represented the release of 1, 2, 3, or more of these packages. The numbers varied from stimulation to stimulation, even at fixed calcium concentration, for the same reason that the minis occurred randomly. By chance, a different number of these transmitter packages would be released on any given trial. At low calcium levels, one can see this quantization, but at higher levels, as under normal physiologic conditions, the nature of large numbers tends to obscure the quantization, since the histogram becomes more and more smeared out.